Okay, so in 12.2, we're going to talk more about the kind of data that's required to come up with a linear regression line or an equation of the line that is able to predict this mean value of some dependent variable. So we're going to look at what we call scatter plots. This is kind of a descriptive statistic that is a graph, a graphical descriptive statistic. So a linear model requires what we call bivariate data, which that word kind of describes what that means. All right, that prefix bi means two. So we need data for two variables from all sample members in whatever sample we're taking from our population of interest. And so what a scatter plot does is it graphs each pair of those values for a particular sample member as a point on the XY axis. And so what this does is it is going to show us what we call the correlation between the two variables. Okay, so if we think about if we've got our XY plane, so X along the horizontal, Y along the vertical. So what we're going to end up with is a point for each sample member. So like we could have one there, one there, one there, one there, etc. All right, so each of those points is related to one value of X, one of the variables, and one value of Y, the other variable. Okay, so you can think of each of these corresponding to those two values. Okay. All right, let's look at an example. Amy plays basketball for her high school and wants to improve. She notices that the number of points she scores in the game goes up in response to the number of hours she practices her jump shot each week. She records the following data. Determine the independent and dependent variables and then create a scatter plot. So we've got two variables here. We've got hours practicing her jump shot and then points scored in a game. Okay, so we want to identify, well, which one seems to be dependent on the other? So which one, seems to be the result of the other one happening? And so that is going to be the points scored in the game. So that's the dependent variable, or Y. Okay, so that's what we're going to count as Y. And then the independent variable is the other one. So the hours practicing is X. All right, so now we're going to plot these on the XY axis. So there is our x-axis, the horizontal, and y-axis, the vertical. And if we can mark off every even value here along the horizontal, along the independent variable. We need to go up to 12 because that is the hours practicing. All right, and then if we count every two as on the vertical as 5, this will work out because we need to go up to 32. Okay, so now we're just going to plot each of those pairs of values. So for week 1, the x value is 5 and the y value is 15. So we go to the right to 5, over to 5, and up to 15, and there's a point. that represents that particular week, okay, which is the first sample member. Second sample member, we've got hours or x of 7 and points of 17 or y equal to 17. So we go over to 7 and then we want to go up to 17, so it's going to be about right there. It's really hard to do just little points with the stylus on the iPad. Okay, next week, the next sample member, we have x equal to 9, y equal to 26. So we go over to x equal to 9, and we want to go up to y equal to 26, so that's going to be about right there. And now we've got x equal to 10, y equal to 30. That gives us this point right here. And next one, week 5, hours practicing, or x is 11, and y is 28. So we go up to about right here. And then the last one, week 6, x is equal to 12 and y is equal to 32. So we get a point. All right, oops, let's get that a little bit closer. Right there. Okay, so that is a scatter plot for this particular set of bivariate data. Okay, where we've got a value for x, a value for y, represented by each of those points. Now, the way that the scatter plot looks can tell us something about the relationship between the variables, and that particular relationship is what we call correlation. So how are x and y correlated? Now, one specific way that we can ask that question is, what happens to y as values of x increase? All right, so as we go to the right, all right, as x values increase, what is happening to y values? Okay, well, in this first case, as x is getting larger as we're going to the right, y values are also going up. They're increasing. All right, if we put a line through the points, we can see that it is, the line has a positive slope because it's increasing. So b, that value b, is going to be positive when we have a positive linear correlation. All right, now the next one, we've got negative linear correlation. Now again, as x gets larger, what is happening to y values? Well, this time they're decreasing. As x gets larger, y values are getting smaller. So this value of x here is relatively small, and the y value is relatively large. All right, but then if we look at this value, this point, that represents a fairly large value of x, but a fairly small value of y, okay, relative to those other points that are plotted. So as x values increase and y values decrease, we call that negative linear correlation. And if we were to draw a line through those points, right, it would be slanting down and the slope is negative. Okay, well, we can have a case where there's no correlation, all right? So as x values are increasing, there doesn't seem to be any pattern with the y values, all right? So the y values do what? Well, no pattern. Okay, there's nothing sort of predictable that the y values are following. We could say, though, that we could draw a line through those and it would be horizontal. And when we have a horizontal line, the slope is actually 0. There's no slope. It's 0. Okay, but there's no linear correlation when the slope is 0. All right, now we can have some other kind of correlation, something that's not linear. Again, as x is getting larger, well, y starts to increase, but then it makes a change and then starts decreasing. All right, and if we put a line through that, right, that sort of looks quadratic. All right, well, we are only interested in linear correlation here. So if it's not linear, y values do what? Something other than a line. They're not, the y values don't follow any linear pattern. And the slope is, well, it's not applicable. Okay, so we are interested in linear relationships between x and y, or linear correlation. So that's all that we're going to be focused on in this section.